let other students join. Meanwhile, let me draw what I want to convey. Okay. Students, put your mic in mute. I don't have mouse. That's why actually I'm taking this much. Yeah, fine. I've done it. Let us say yes, we got a good count. Yeah. You see the students, once you write the source code, let us assume I've written a Java code. We call this as source code. So once you write the source code, you're going to compile the program. Once you compile the program, you're going to get the corresponding .class file. And we call this .class file as the bytecode. Okay. So once the compilation is successful, next what you're going to run the program. Okay. See, that's what it says. Call to a method is resolved during runtime. That is here. Call to, what is called to? Students, please put your mic in mute. Likit Krishna. Good. Okay, fine. See, and that's what. So I've compiled it. Once I compile, I'll get .class file. So once I get a .class file, next I'm going to run the program. So at runtime, at this point, at runtime, I'm going to resolve. So which method I need to call at runtime. So at the time of running the program, I'm going to resolve which method I need to call. In other words, here when you write c.callback. So this c.callback means which callback method I need to call. Which callback method I need to call. This statement will be resolved during runtime, not during compilation time. Okay. Whereas as you see here in the next set of statements, okay, if I write a dot callback, something like this. So call to this function. So call to this function is resolved during compilation time. So that's the difference between using reference variable and not using reference variable. Okay. In first case, you see that I have used interface reference variable. So when you're trying to call any method with respect to interface reference variable, then call to a method is resolved during runtime. Means so at the time of running the program, I'm going to decide which callback method I need to call. Okay, but if you're not using interface reference variable, if you're trying to use a class reference variable, then call to a function, then call to a method is resolved during compilation time. Okay, that's the difference between these two. And now let me illustrate the importance of this. Okay. Let me do it. One more thing here. Now, let me put it. We call this as dynamic method dispatch, right? We call this as dynamic method dispatch. What is dynamic method dispatch? That's what it is. Call to a method is not. Call to a method is resolved during runtime. So we call this as dynamic method dispatch. So this is an example. So this is an example with respect to this dynamic method dispatch. Why dynamic method dispatch? Because call to this function, that is call to this method called callback, is resolved during runtime, and therefore we call this as dynamic method dispatch. Anyhow, fine. One more thing I would like to illustrate here. Example. Students, can you please fill out this program? So I have totally 3 classes, class A, class B, and class demo. So inside this class demo, I have written the main method. Yeah. Okay, tell the output of this program. Just give a try. Yes, come on, students. Can you give a try? What's the output? Yes, Ritu, what's the output? Niharika, Likit, Chandani, Priyanka, Sukrut. Can you guess the output of this program? Yes, Padmaja, what's the output? Any guess? Okay, fine. So I hope you can see my screen, right? Yeah, I think you can see my screen. Yeah. So, and you can see here students. Okay, so totally I have written 2 classes. One is class A and one more is class B. So these both classes are trying to implement interface called callback. Okay, so a n number of classes can implement same interface. There's nothing wrong. Okay, a single interface can be implemented by n number of classes. There's no constraint. So since class A has implemented callback, we should not think that class B cannot implement callback. No, that's wrong. Okay, a class can implement. Okay, so any class can implement any interface. Okay, so here my class A has implemented callback interface, and similarly the class B has implemented this callback interface. So since they both are implementing this callback interface, both class A has implemented the method which is present in callback interface, and similarly class B also has implemented the method which is present in callback interface. And one more thing, and let me, oh, sorry, a small mistake here. Let me remove this argument here. Okay, my focus is not towards this argument. So if I put int, the here also I need to pass the value called 10. Okay, I will not pass the value. Okay, that's what actually I removed this. Okay, okay, fine. I hope I understood this. Okay, now so I've done with class C and class B, and next let us move to a class called demo. And inside this class called demo, I have the main method. Now, inside this main method, as you notice that I've created an object of a class called A. I've created an object of a class called A. So object of this class. Is that right, students? Object of this class I've created. Now C is a reference variable. Now C is a reference variable. C is a reference variable which is referring to the object of a class called A. That's very, very important. Okay. Now C is a reference variable which is referring to the object of a class called A. So now when I call C dot callback, so when I call C dot callback, okay, so which callback I'm trying to call? I'm trying to call the callback method which is present in class called A. Why? Because as you see here in the above statement, this interface reference variable is referring to the object of a class called A. So since interface reference variable C is referring to the object of a class called A, when I write C dot callback, I'm trying to call the callback method which is present in the class called A. Okay. So therefore, so in the output, I'll get first hello. In the output, I'll get first hello. Okay. Hello. Okay. And next you see that here, I've done a small mistake here. Actually, as you create an object of a class called, I'm sorry for that. I'm sorry for the students. Okay. Okay, fine. And next, as you see here, so what I'm doing at the next line, Next statement, I'm trying to create an object of a class called B. Okay, next I'm trying to create an object of a class called B, and B is a reference variable which is referring to the object of a class called B. Now, in the subsequent statement, you see that what is C? C is nothing but it's an interface reference variable. Now, you see that now this interface reference variable C, now it is referring to the object of a class called B. Now, since this interface reference variable is referring to the object of a class called B, in the next statement, if I write C dot callback, in the next statement, if I write C dot callback, now I'm going to call the callback method, which is present in class called B. Why? Because as you see that in this line, when write C equal to B, in this line, write C equal to B. Now C is an interface reference variable, which is referring to the object of a class called B. Now, since it is referring to the object of a class called B, so when I write C dot callback, I'm going to call the callback method, which is present in class called B. So therefore, in the output, I'll get good. So the output of this program is hello and good. Hello and good. Okay. So that's what it is. So that's what I said here. Okay. So with respect to interface reference variable, we can implement what we can implement. We can implement dynamic method dispatch. So you see that here. You see that what's going to happen here at runtime. At runtime, I'm going to see. That's what at this point. That's what at runtime. At runtime. So this is the runtime. At runtime, I'm going to see. Okay, so the reference variable is referring to which object. So at runtime, I'll check. Since reference variable C is referring to the object of a class called A, when I encounter the statement C dot callback, I need to call the callback method, which is present in class called A. Okay. Next, you see that, and again, when it come to this statement, at runtime it checks. So this reference variable C is referring to which object. So in the above statement says that C is a reference variable which is referring to the object of a class called B. So therefore, at runtime, it's going to resolve that I need to call a callback method which is present in class called B. So this is an example of dynamic method dispatch. Dynamic method dispatch. What is this dynamic method dispatch? Call to a method is resolved during runtime, but not during compilation time. Okay. So call to a function is resolved during runtime, and we call this as dynamic method dispatch. So that's all for today's class, students. Have a nice day. In case you have any questions, you're welcome. I'm ready to take your questions. Any questions, students? Any questions? I'm ready to take. Otherwise, you can leave the session, and that's all for today's class. Have a nice day.
Thank you, sir.
Thank you.